The full system of wind turbine involves all the components and processes needed to convert wind energy into electricity. It all begins with the rotor blades. These blades capture the kinetic energy of the wind, causing the rotor to spin. This spinning creates rotational energy, which is transferred through the main shaft to the gearbox. The gearbox plays an important role by increasing the rotational speed to a level that is suitable for electricity generation. Next, the generator converts the mechanical energy from the spinning shaft into electrical energy. But the process doesn't stop there. The electricity generated must be conditioned and transmitted. This is done using transformers and grid connection systems so that the power can be safely and efficiently delivered for public or industrial use. Each part of the system works together to make sure the entire process is efficient, reliable, and sustainable, supporting the growing demand for clean energy from wind. First, let's look at the significance of wind turbine sources. Firstly, wind turbines support clean energy transition by reducing our dependence on fossil fuels. They generate electricity using wind, which is a renewable, eco-friendly, and naturally abundant resource. This helps in minimizing carbon emissions and contributes to a more sustainable energy system. Secondly, wind energy systems encourage innovation and research. With detailed knowledge, we can develop better turbine designs, improve control systems, and enhance energy storage. This leads to increased efficiency and better long-term performance of the entire system. Thirdly, wind energy contributes to sustainable development goals. It aligns with global efforts to provide affordable clean energy, address climate change, and promote sustainable industry through low-impact power generation.
Hi, my name is Amira Yudina binti Muhammad Anuddin, and today I want to give an explanation of the relevant scientific instrumentation and the application concept. Number 1 is the wind speed and direction sensors. The main purpose is to detect the real-time wind conditions to decide when to start, stop, or adjust the turbine operation. The example is ultrasonic anemometer. It has no moving parts and it will measure the wind speed with ultrasonic pulses. Next, the wind vane. It will measure the wind's azimuthal direction, critical for your system alignment. Next, for the application is, if the wind speed is greater than 25, it will automatic emergency shutdown. Next is vibration sensors. The main purpose is to identify the mechanical imbalance in blades, motor, or gearbox bearings. The example is piezoelectric accelerometer. It will detect the subtle vibration anomalies. And lastly, the application is it will alert the operator to inspect the blade cracks or bearing faults. Last but not least is data loggers and SCADA systems. The purpose is to collect, process, and remotely monitor the sensor data. The example is SCADA. It will control the turbine remotely via cellular or fiber networks. Number 2 is data logger. It logs the power output, temperature, and wind speed for later analysis. The application is the operator in control room can shut down the turbine in storms via SCADA.
Next, the exploration of a system of wind turbine sources. In order to transform wind energy into electrical power, a wind turbine system combines a number of intricate parts. The nacelle, which houses the gearbox, generator and controller, the tower, the electrical system, and the rotor, which is blades and hub, are the main subsystems that make up the system. The wind's kinetic energy is captured by the rotor, which usually consists of 3 aerodynamic blade sets on the hub that rotates in response to wind, utilizing lift and drag forces. In geared system, the gearbox receives this mechanical rotation and raises the rotational speed appropriate for the generator's conversion into electrical power. Direct drive system, which do away with the gearbox, are used in several contemporary turbines to minimize maintenance. Power electronic can then convert the AC electricity produced by the generator to DC and back to grid compatible AC. Blade pitch, yaw, wing direction, and other parameters are adjusted by the controller to guarantee maximum performance and safety. The tower provides support for the entire system and raises it to altitudes with more stable and powerful winds. To move power to the grid, electrical subsystems use cables, transformers, and inverters. For instance, the GE Halide X offshore turbine is one of the most potent systems in the world, with a direct drive generator capable of producing up to 14 and the other types of wind turbine system, which is onshore and offshore. Each is made to fit specific logistical and environmental requirements. Although offshore turbines, such as those employed in the UK's Dogger Bank project, benefit from stronger and more consistent winds, they are more difficult to install and maintain. On the other hand, onshore systems are simpler to set up and use, but they frequently face more unpredictable wind conditions. All things considered, wind turbine systems represent a multidisciplinary engineering feat, effectively combining mechanical, electrical, and control systems to capture a clean and renewable energy source.
So as for my part, there are three top examples of real-world implementation. So one of them is one is currently the world's largest offshore wind farm. It is located in the North Sea of the coast of Yorkshire in the UK. This wind farm uses 174 large turbines, each producing 7 megawatts with a total capacity of 1.2 gigawatts, enough to power over a million homes. This what makes this system complete is that it includes offshore substations, undersea power cables, and a full monitoring and control system. The electricity is transmitted to the mainland and integrated into the national grid. This project shows how offshore wind can generate massive amount of clean energy at a national scale. Next is Sam's Island. Sam's Island is a small island in Denmark that became the world famous for being energy self-sufficient. The island installed 11 onshore and 10 offshore wind turbines to meet all its electricity needs. What makes Sam special is that the wind system is owned by the local community and it's fully connected to the island's grid. They also use solar panels and biomass heating to cover other energy needs. Sam's is a great example of how a wind full turbine system generation, storage, and community involvement can work together to achieve 100 renewable energy. And for the last one is the Gansu Wind Farm, also known as the G1 Wind Power Base, is one of the biggest onshore wind farms in the world. It's located in Gansu Province, China, where there is a lot of open land and strong wind. The project includes thousands of wind turbines and it's planned to reach 20 gigawatts of capacity. To support this, China built long-distance transmission lines using a high-voltage direct current or HVDC to send power to major cities. Gansu shows how wind energy can be scaled up massively, but also highlights the importance of strong infrastructure to deliver the electricity to where it's needed. So there are top 3 potential benefits for wind turbine. First is wind energy is a clean and renewable energy source. Wind is naturally available and never runs out. Unlike fossil fuels, wind turbines produce no harmful gases like carbon dioxide. This makes wind power a great way to help reduce air pollution and fight climate change. Second, wind energy offers low long-term costs. Although building wind turbines can be expensive at first, The system has low maintenance costs and doesn't require fuel, which means it can help lower electricity bills over time. Third, wind turbines improve energy security and independence. By using wind, countries can rely less on imported fossil fuels and instead produce their own electricity. This makes the energy supply more stable and reliable, especially during energy crisis. So in conclusion, wind turbine systems are not only good for the environment, but also economically smart and strategically important for the future of energy. So these are the challenges of wind turbine system. First, wind energy is intermittent and unpredictable. This means the wind doesn't blow all the time or at the same speed. Because of that, the electricity produced by wind turbines can change throughout the day. This makes it harder to always meet the energy demand. To solve this, we need to add batteries or backup energy sources, which can increase the overall cost. Second, there are high initial costs. Building wind farms and installing turbines costs a lot of money. This includes the price of the turbines, construction, and connecting to the electrical grid. Even though wind energy is cheap, in the long term, the first investment is a big challenge, especially for developing countries. Third, we face grid integration challenges. The power grid is not always ready to handle the changing output from wind turbines. In some areas, the electrical system is too old or weak to support large-scale wind energy. This means we need to upgrade the grid, which takes time, planning, and money. In conclusion, while wind energy has many benefits, these three challenges, intermittency, cost, and grid integration, must be addressed to make wind more reliable and efficient.
On to the next one, future development and innovation. For the first innovation, use larger and more powerful turbines. Future turbines are being designed with higher capacities, which is 15 to 20 megawatt, and larger rotor diameters to 220 plus meters. Example, GE's Highlight X and Siemens Gamesa SG14 222 TD turbines. The next one, advanced blade materials and design. Use of lightweight durable materials like carbon fiber reinforced composites to reduce weight and increase flexibility. The third one, floating wind turbine technology. Enables deployment in deeper waters where wind is stronger and steadier. For the example, High Wind Scotland, which is the world's first commercial floating wind farm. Last one, energy storage integration. Wind farms are being coupled with battery system and green hydrogen production to store excess energy. It ensures stable power supply even when wind conditions fluctuate.
So in this slide is conclusion. In conclusion, wind turbine system represent a highly sustainable and efficient method of generating electricity by harnessing the natural power of the wind through a detailed exploration of the full system from the aerodynamics of turbine blades to the electrical conversion, storage and integration into the grid. That the renewable energy source has been shown to reduce dependence on fossil fuels and minimize environmental impact. Scientific instrumentation such as anemometers, tachometers, and control system ensure optimal performance and safety, while power electronics enable the smooth conversion of mechanical energy into usable electrical energy. Overall, the wind turbine system is not only a technical innovation but also a critical step towards achieving global energy sustainability. As the world shifts toward cleaner energy, wind power continues to play a key role in meeting energy demands while reducing carbon emission.